right, let's get it. Let's get it. All right, so some problems. There's our by parts. U times some dv is equal to u times v minus the integral of v du. And here's our classic problem to start off. Pretty much every textbook I look in to get some good entry-level problems, and they all start off with this problem, x times sine of x dx. So our game is we want to find a u, and we want to find a dv. All right, got to find a u, got to find a dv. Well, there's only two frickin' options. All right, we could say u is sine of x. We could say dv is x dx. We could say u is equal to x, and dv is equal to sine of x dx. And I think that's the way we want to go. So we're going to call that u. And we're going to call dv this whole piece. We take the dx along with it. So let's jump off to the side. So if u is equal to x, and our dv, I'm trying to do it the same way as your textbook. This is not the way that my brain sees it. So now what we need to do is, well, we're looking up top and we're like, well, we need v and we need du. So let's take a derivative on u, and that's just dx. Okay, and now our next one, and this is where it gets confusing. So we're going to take an antiderivative on sine of x dx. I believe that to be negative cosine of x. So whatever your d's are, like your du and your dv's, they need to have the dx's in them, okay? And whatever your u and your v are, they will not have either. So let's use our formula now. So it says we need to take our u times our v. That's our x times our x times negative cosine of x. There's our u times v minus the integral of v du. We don't mess with this one. This one gets left alone. Okay, so that's not part of the problem. So now we have the integral of v du, which is negative cosine of x dx. Right, our v being the negative cosine of x, our du just being our dx. So let's clean it up and let's solve. Let's see what we got. So that's negative x cosine of x. Nothing to do to that. That's done. Now let's take that negative and let's create a positive and say it's cosine of x dx. Well, shoot, that's going to be the easiest integral we do all day, huh? Finding the antiderivative of cosine of x, well, that's just sine of x. And then we use plus c. And there's our solution. Oh my goodness. The integration by parts. You gotta see the pattern a few times. You gotta see it the first time. No big deal. Keep going. Let's deal with this bad boy. Let's go finally figure out what is the antiderivative of the natural log of x. Now this one, there's not two pieces. Notice before we had x times sine of x dx. This is just telling us, it's begging us. It's begging us. So we have to find a u and a dv, don't we? Don't we? Isn't it the integral of u times dv is equal to u times v minus the integral of v du? Okay. So let's find a u. I think the simplest u we could find would just be ln of x. And I think the simplest dv we could find would just be dx. So let's take it aside. So u is equal to the natural log of x. And then our dv is equal to just dx. Or how about this? 1 times dx. 1 times dx. All right. Well, let's go get our du. That's just going to be 1 over x, but don't forget we need that dx in there. Because anything with the du's, dv's, they got to have the dx in them as well. And now we have to find the antiderivative of 1. That's just x. Now let's use our formula. So it's going to be u times v, ln of x, times x. X, ln of x, minus the integral of v du. So that's going to be x times 1 over x dx. Oh, that's a pretty simple antiderivative. I think that's just going to be minus x. And then just don't forget, plus c. And there's our solution. That's the antiderivative of the natural log of x. X ln of x minus x. Plus c, of course. Keep on going. We just got to catch this pattern. Got to catch this pattern, so we're just going to continue moving. Oh. Here we be. Here we be. Let me change these. Let me keep everything in terms of x's for now. Wow. Come on, man. Come on, you can do this. Yay, I did it. All right. Now we have a couple different choices. We want to find our u, and we want to find our dv. Now, the game is we kind of just want, you see an x squared, an x cubed, an x, that's typically what you're going to want to choose for u. Because we're going to want those powers to reduce. Like this is going to be, we're actually going to have to do by parts twice on this problem. So let's say that our u is equal to x squared, which means that our dv must be the remaining piece, the e to the power of x dx. All right. So let's take a derivative on u. So du is equal to 2x dx. Our v is just equal to e to the x. Because e to the x, that's nice. I thought we were going to take the easiest antiderivative, but nope, there it is. E to the x is the best. So we're going to say that this is equal to u times v, so x squared times e to the x, minus the integral of v du. 2x e to the x dx. Crap. We're not done. Oh, man. But do you see that what we started with was an x squared e to the x? And now we've gotten down to, we lost a power on our x? That's good news. That's good news. We just have to do it one more time. Just one more time. So now our u is equal to 2x. And our dv is equal to e to the x dx. Well, shoot, let's just write it. We know that one. And let's say our du is equal to 2. So let's just keep moving on down. There's also something called the tabular method. Maybe I'll show it in a while. I don't know. So first, we need to do our u times v. So 2x e to the x. Notice how I used a parenthesis. That sign needs to travel through. It's the integral of v du. Oh, I forgot to write it in. What a bad teacher. Bad teacher. The the derivative of 2x is 2 dx's. All right. Well, let's distribute in our negative and let's see what we can do. Yeah, that's not so bad. So we have x squared e to the x minus 2x e to the x plus 2 e to the x's plus c. And of course, you can factor some stuff out. You can do something strange. Yeah. There it is. This is by parts. By parts. You just have to get the process down. The first time you see it is probably quite a bit, but it's just a process. It's just the same thing. And there's only ever two choices. There will be times when you choose your dv wrong. You mix up your u and your dv. Whatever. There's only two options. If you get it wrong, go to the next one. It will happen. You are going to go the wrong direction. It's all right. We'll be good. All right. Well, we'll do one of the classics in the next video, and maybe some tough stuff. All right.